Today, I would like to introduce our work accepted by CVPR 2026, Scalable Object Relation Encoding for Better 3D Spatial Reasoning in Large Language Models. We focus on 3D vision language tasks that take 3D point cloud scenes and natural language as input and output textual responses. The core ability required is spatial reasoning, that is, locating a target object according to its spatial relations with other objects in the scene. Typical tasks include 3D visual grounding and 3D visual question answering. The scarcity of 3D scene text paired data makes training a strong spatial reasoning model from scratch hard. With advanced large language models, prior works inject point cloud representations into LLMs and leverage their pre-trained reasoning ability for 3D spatial reasoning. So the next question is, how to effectively represent 3D positions in the scene? Existing methods adopt absolute or relative object position encoding. Absolute position methods integrate 3D coordinates as features. Since absolute coordinates lack natural physical meaning and fail to explicitly express relative geometry, models need to inefficiently learn relations from scarce data. Premature feature fusion also blocks position extraction and pairwise relation computation. For methods that directly encode pairwise object relations using tokens, the number of tokens grows quadratically and does not scale, while pruning strategies may omit critical relations and hurt accuracy. To address these challenges, our method has three core properties. Scalability with linear input tokens by applying positional embedding to object feature tokens, completeness by retaining all pairwise relations via attention layer dot product for relative positions calculation, and accuracy by letting attention scores correctly reflect object relative positions. To meet these requirements, we propose a novel rotary positional embedding method named QuatRoPE. For scalability and completeness, dot products between tokens rotated by QuatRoPE relate only to object relative positions instead of absolute ones. Formally, the requirements yield the equation at the top, which gives an approximate solution that can be used to rotate object feature token vectors. Unlike prior works that encode each coordinate independently, which leads to incorrectly inflated attention scores when coordinates on one axis are close, QuatRoPE encodes 3D positions as holistic vectors using quaternion rotations. This design ensures that attention scores truly reflect 3D spatial proximity. Since both QuatRoPE and the original language rope in LLMs perform rotation on tokens, they may interfere with each other. To solve this, we propose the isolated gated rope extension. We extend dedicated dimensions on object feature tokens for QuatRoPE rotation and use zero padding for other tokens. This isolates QuatRoPE from language rope and gates its effect to object feature token pairs, thus preserving the original language abilities of LLMs while enabling strong spatial awareness. To rigorously evaluate pure spatial reasoning ability, we propose the attribute-free spatial reasoning benchmark. Existing benchmarks mix spatial relations with object categories or attributes, allowing models to rely on detection rather than reasoning. In contrast, ASR omits category and attribute cues and uses only spatial descriptions. It also adopts the multiple choice setting in visual grounding to eliminate language generation ability biases. For the experiments, we utilize the Scan Refer and Multi-3D Ref datasets in 3D visual grounding and the SQA 3D dataset in 3D visual question answering. Applying QuatRoPE brings consistent metric gains on mainstream 3D vision language benchmarks, proving its effectiveness in conveying spatial relations. QuatRoPE also achieves large and steady gains on the ASR benchmark, directly verifying that it greatly enhances LLM's pure spatial reasoning without attribute cues. Ablation studies show IGRE reduces interference and outperforms joint rotation with language rope. QuatRoPE surpasses mRoPE and raw coordinate addition, confirming the importance of holistic positional encoding. Qualitative results show that QuatRoPE better matches spatial descriptions like surrounded by and next to, which complies with human pragmatic implications by selecting the closest relevant object, behaving more naturally in real-world interactions. In conclusion, first, we propose QuatRoPE, a 3D positional encoding method with linear input complexity that provides full pairwise object relative positions. Second, we propose IGRE to minimize interference between QuatRoPE and language rope. Third, we construct the ASR benchmark for exclusive evaluation of 3D spatial reasoning. Fourth, we achieve consistent and large margin gains on both ASR and existing 3D vision language benchmarks, validating the effectiveness of our method. Thank you for listening. For more details, please visit our project page, read the full paper, or check out the code.